The gradient of a curve is 2px plus 3, where p is a constant. If the curve passes through the points into bracket minus 2 and 0 and into bracket 1 over 2 and 0, find p. So the gradient is dy dx, and that is equal to 2px plus 3. However, we are told that p is a constant. So let's multiply both sides by dx. So this dx and dx cancel. So dy is equal to into bracket 2px plus 3 dx. So we can find y by finding the integration of both sides, and therefore y is equal to the integral of 2px plus 3 dx. So let's go ahead and do the integration. So y is equal to, if you integrate x, it becomes 1 over 2 times x squared. So this is 2p times 1 over 2 x squared plus, if you integrate 3, you get 3x. Then plus the constant of integration. In this case, let me use a. So y is equal to, this 2 and 2 cancels. So that becomes px squared plus 3x plus the constant of integration a. However, the question says at this point, minus 2, 0 and half 0 passes through y. So it means that we need to insert these 2 points in this equation, find the values of p and a. So at the point minus 2, 0, what happens? It means that y is 0, and wherever we see y, we put 0, and wherever we see x, we put minus 2. So 0 is equal to p times minus 2 squared plus 3 times minus 2 plus a. So 0 is equal to minus 2 squared is 4 times p is 4p. Then 3 times minus 2 is minus 6. Then plus a. And therefore 4p plus a is equal to 6. This is equation 1. Then let's also check at that point 1 over 2, and then 0. So wherever we see y, we put 0. Wherever we see x, we put 1 over 2. So 0 is equal to p times 1 over 2 squared plus 3 times 1 over 2 plus a. So 0 is equal to 1 over 2 squared is 1 over 4 times p, becomes p over 4, plus 3 times 1 over 2 is 3 over 2 plus a. So in this case, let's multiply through by 4. 4 times 0 is 0, equals 4 times p over 4 is p, plus 4 times 3 over 2 equals 2 times 3, because 4 divided by 2 is 2, times 3 is 6, plus 4 times a is 4a. So in this case, this implies that p plus 4a is equal to minus 6. And this is our equation 2. So we have to take equation 1 and equation 2 and solve them simultaneously. So let me write equation 1. Equation 1 is 4p plus a equals 6. Equation 1. And equation 2 is p plus 4a equals minus 6. Equation 2. So let's multiply equation 2 by 4. And this becomes 4 times p is 4p plus 4 times 4a is 16a equals 4 times minus 20 minus 6 equals minus 24. And this is equation 3. So there's 4p and there's 4p here. So let's subtract equation 1 from equation 3. So it becomes 4p minus 4p, which is this minus this, and plus this term, which is 16a, then minus this term, which is a, equals minus 24 minus this term, which is 6. So 4p minus 4p is 0. Then 16a minus a equals 15a equals minus 24 minus 6 equals minus 30. So if you divide through by 15 and divide here 2 by 15, a is equal to minus 30 over 15 is minus 2. So since we've gotten a equals minus 2, then what we need to do is to put the value of a and find into equation 1 and find the value of p. So from equation 1, 4p then plus a, in this case a is minus 2, is equal to 6. So 4p is equal to 6 plus 2. So 4p is equal to 8. And therefore p is equal to 8 over 4. So p is equal to 8 over 4, which is equal to 2. The gradient function of a curve at any point xy is px squared plus 3x minus 2, where p is a constant. If the curve passes through the points 1, 0 and minus 1 and 8 over 3, find I, the value of p, I, the equation of the curve, and I, the coordinates of the maximum point on the curve. So this example also sounds like, so this example is the same as the previous example. So the gradient function is px squared plus 3x minus 2. So this means that dy dx is equal to px squared plus 3x minus 2. So as usual, you multiply this side by dx, and then you multiply this portion too by dx. So this dx and dx cancels out, and therefore dy is equal to px squared plus 3x minus 2 dx. So that to find y, we can take the integral of both sides, and therefore if you integrate dy is equal to y is equal to, so y is equal to integral of p x squared plus 3x minus 2 dx. So let's go ahead and do this integration. So y is equal to, if you integrate x squared, it becomes 1 over 3 x cubed. So this is p over 3 x exponent 3 plus, if you integrate x, it becomes 1 over 2x cubed. So this 3x becomes 3 over 2 x squared. Sorry, if you integrate, okay, minus, if you integrate 2, it's equal to 2x, so minus 2x, then plus the constant of integration c. So the integral y is equal to p over 3x exponent 3 plus 3 over 2x exponent 2 minus 2x plus c. However, the question says that it passes through this point 1, 0 and minus 1 and 8 over 3. So we need to substitute 1, 0 and minus 1 and 8 over 3 into this equation and find the value of c. So at the point 1, 0 means that wherever we see y, we insert 0, and wherever we see x, we insert 1. So this implies that 0 is equal to p over 3 times 1 exponent 3 plus 3 over 2 times 1 exponent 2 minus 2 times 1 plus c. So 0 is equal to 1 exponent 3 is 1 times p over 3 is 3, p over 3 plus 1 exponent 2 is 1 times 3 over 2 is 3 over 2. Then minus 2 times 1 is minus 2 plus c. So minus 3 over 2 minus 2 is equal to minus 1 over 2. So 0 is equal to p over 3 minus 1 over 2 plus c. So let's multiply through by 6. So 6 times 0 is equal to 6 times p over 3 is equal to 2p. And 6 times minus 1 over 2 is minus 3 plus 6 times c is 6c. So in grouping like terms, it implies that 2p plus 6c is equal to, I'm taking minus 3 to across the equal sign, so this is equal to 3. So 2p plus 6c is equal to 3. Let us also check at the point minus 1 and 8 over 3. So in this case, y is equal to 8 over 3 and x is equal to minus 1. So 8 over 3 is equal to p over 3x cubed, so which is p over 3 times minus 1 cubed, then plus 3 over 2 times minus 1 squared, then minus 2 times minus 1 plus c. So 8 over 3 is equal to minus 1 cubed is minus 1 times p over 3 is minus p over 3. Then minus 1 squared is 1 times 3 over 2 is plus 3 over 2. Then minus 2 times minus 1 is plus 2 plus c. So 3 over 2 plus 2 is equal to 7 over 2. So 8 over 3 is equal to minus p over 3 plus 7 over 2 plus c. So I want to bring 7 over 2 across the equal sign. So it becomes 8 over 3 minus 7 over 2 is equal to c minus p over 3. I want to multiply 8 over 3, this fraction by 2 over 2. So 2 times 8 is 16 divided by 2 times 3 is 6 minus, I want to multiply this fraction by 3 over 3. 3 times 7 is 21 divided by 3 times 2 is 6 equals c minus p over 3. So 16 minus 27. Sorry, 3 times 7 is 21. Made a mistake. So now 16 minus 21 is 5 over minus 5 over 6 is equal to c minus p over 3. So let's multiply through by 6. 6 times minus 5 over 6 is minus 5 equals 6 times c is 6c. Then 6 times minus p over 3 becomes minus 2p. So in other words, 6c minus 2p is equal to minus 5. So I want to multiply through by minus 1. So if I multiply through by minus 1, it becomes minus 6c plus 2p equals 5. And rearranging, it becomes 2p minus 6c equals 5. So this is equation 2. So we now have our two equations, which is the first equation, which we got as 2p plus 6c equals 3, equation 1, and this equation 2 to solve simultaneously for the values of p and c. So let's write down, remember that our integral y we got as y equals p over 3 x exponent 3 plus 3 over 2 x exponent 2 minus 2x plus c. Then the equations we have, equation 1 was 2p plus 6c equals 3. This is equation 1. Then we go equation 2 as 2p and minus 6c equals 5. This is equation 2. So minus 6c plus 6c minus 6c, if we add equation 1 and 2, that portion will go to 0. So we'll get 2p plus 2p equals 3 plus 5. So 2p plus 2p is 4p equals 3 plus 5 is 8. So if you divide through by 4, you see that p is equal to 8 over 4, which is 2. So let's put p in equation 2 and find the value of c. So from equation 2, 2 times 2, okay, so let me do it here. Equation 2 is 2p minus 6c equals 5. So let's make c the subject. So I'm taking c to the side and bringing 5 to the side. So 6c is equal to 2p minus 5. And dividing through by 6, we find out that c is equal to 2p minus 5 over 6. So let's substitute the value of p equals 2. So c is equal to 2 times 2 minus 5 over 6. 2 times 2 is 4. 4 minus 5 is minus 1 over 6. And therefore the value of c is minus 1 over 6. So therefore, the question says that we should find the equation of the curve. So the equation of the curve y is equal to p 2 over 3 x exponent 3 plus 3 over 2 x exponent 2 minus 2x, then plus c. c is minus 1 over 6. So this is the equation of the curve. The second portion of the question says we should find the coordinates of the maximum point. So to find the maximum point, what we need to do is to find y prime. So y is equal to 2 over 3x cubed plus 3 over 2x squared minus 2x minus 1 over 6. And the question is saying we should find the maximum point. So to find the maximum point, we need to first find y prime of x. So let's differentiate this function. It becomes 3 times 2 over 3 x squared minus 2 times 3 over 2 x, then minus 2. If you differentiate, minus 1 over 6 is a constant, and you differentiate it is equal to 0. So y prime of x is equal to, this 3 and 3 can cancel, and this 2 and 2 can also cancel. So it becomes 2x squared, then minus 3x minus 2. However, to find the maximum point, we need to first set y prime of x equals 0 to find the x component of the point. So this implies that 2x squared minus 3x minus 2 is equal to 0. So 2 times minus 2 is minus 4. We need to find two numbers that when you multiply, you get minus 4, but when you add, you get minus 3. And those points are 4 and minus 1. Sorry, there's a mistake here. Here's plus. It was 3 over 2 plus. So here's plus, and therefore this place 2 is plus. So 2 times minus 2 is minus 4. So we need to get two numbers that when you multiply, you get minus 4, but when you add, you get 3. And those numbers are 4 and minus 1. So this becomes 2x squared plus 4x minus x minus 2 equals 0. So let's factorize 2x from these two. So we are left with x plus 2. And let's factorize minus 1 from this portion. We are left with x plus 2 equals 0. So in one bracket we have 2x minus 1. And in another bracket we have x plus 2 equals 0. So x is equal to minus 2, or x is equal to 1 over 2. So, but then we are looking for the maximum point. So these two x values will give us a corresponding y value. But which of them will be maximum? We can only know that by finding the second derivative of y. If the second derivative of y of x, that is y prime prime of x, is less than 0, among these two x values, the one that if we substitute x in y prime prime of x, the value of y prime prime of x is less than 0, will give us the maximum point. So therefore, let's find y prime prime of x. And this is equal to, so we take y prime of x and further differentiate. If we differentiate 2x squared, we get 4x. And if we differentiate 3x, we get plus 3. And if you differentiate minus 2, it's equal to 0. So y prime prime of x is equal to 4x plus 3. So let's find y prime prime of the first one, which is minus 2. And this is equal to 4 times minus 2 plus 3. 4 times minus 2 is minus 8 plus 3. And then minus 8 plus 3 is equal to minus 5. So you see that minus 5 is less than 0, and therefore the value that will give us the maximum point is y of minus 2. But we can also test for x of 1 over 2. Let's find y prime prime of 1 over 2. This is equal to 4 times 1 over 2 plus 3. 4 divided by 2 is 2. So 2 plus 3, and 2 plus 3 is 5. And then 5 is greater than 0. So this will give us the minimum point. And then this one will give us the maximum point. So we need to take x equals minus 2 and put it back into the y equation to find the maximum point. So the maximum point is y of minus 2. And this is equal to 2 over 3 times, let me do it here, y of minus 2 equals 2 over 3 times minus 2 exponent 3 plus 3 over 2 times minus 2 squared minus 2 times minus 2 minus 1 over 6. So y of minus 2 is equal to minus 2 cubed is 8. 8 times 2 is 16 over 3. The minus 2 squared, minus 2 cubed is minus 8. And minus 8 times 2 is minus 16 over 3. The minus 2 squared is 4. 4 times 3 is 12. So this is plus 12 over 2. The minus 2 times minus 2 is plus 4. Minus 1 over 6. So y of minus 2 is equal to minus 16 over 3. Let me bring this here. Minus 1 over 6. Then plus 12 divided by 2 is 6. 6 plus 4 is 10. So this is plus 10. And y of minus 2 is equal to, I want to multiply this fraction, the numerator and denominator, by 2. So minus 16 times 2 is minus 32 over 6 minus 1 over 6 plus 10. So y of minus 2 is equal to minus 32 minus 1 is minus 33 over 6 plus 10. So this is equal to 6 times 10 is 60 minus 33 plus 60 is equal to 27 divided by 6. And 27 divided by 3 is 9. And 6 divided by 3 is 2. So it's equal to 9 over 2. And 9 over 2 is equal to 4.5. And therefore, the maximum point is equal to minus 2 and then 4.5. Sketch the curve y is equal to into bracket 1 minus 3x times into bracket x plus 2. And then calculate the area of the finite region bounded by the curve y and the x-axis. So from the question, y is equal to into bracket 1 minus 3x and into another bracket x plus 2. So let us expand the brackets. So y is equal to, we take this 1 times and multiply by all of the second bracket, which is x plus 2. Then minus 3x times x plus 2. So y is equal to 1 times x is x, 1 times 2 is plus 2. And minus 3x times x is minus 3x squared. Then minus 3x times 2 is minus 6x. So y is equal to then 2, then x minus 6x is minus 5x. Then we are left with minus 3x squared. Having found y, let us go ahead and find the y-intercept. So y-intercept. And then we know that for the y-intercept, x is equal to 0. So let's find y of 0. This is equal to 2 minus 5 times 0 minus 3 times 0 squared. This part will give us 0. So y of 0 is equal to 2. So we have the point 0, 2 as the y-intercept. So let me continue from here. Let's find the x-intercept. So let's find the x-intercept. And then for the x-intercept, y is equal to 0. So y is equal to 0 in this case. So we take all of this function and equate it to 0, which is into bracket 1 minus 3x, then times into another bracket x plus 2 is equal to 0. So x is equal to 1 over 3, or when we consider this bracket, x is equal to minus 2. So we also have the x-intercept as 1 over 3 and 0, and then minus 2 and 0. Let's go ahead and find y prime of x. So y of x is equal to 2 minus 5x minus 3x squared. Y prime of x is equal to, if you differentiate 2 is a constant, so it's 0. If you differentiate minus 5x, you get minus 5. And if you differentiate minus 3x squared, it becomes minus 6x. So the turning point occurs at where y prime of x is equal to 0. So we take all of this function equate to 0, which is minus 5 minus 6x is equal to 0. So let's take 6x to the side of the equation. Minus 5 is equal to 6x. So if we divide through by 6, we find out that x is equal to minus 5 over 6. This minus 5 over 6 is equal to minus 0.833. So having found the value of x, let's go ahead and then put this value of x into the function y and then find the y component of the turning point. So y of 0 minus, let me write it here, y of minus 0.833 is equal to 2 minus 5 times minus 0.833 minus 3 times minus 0.833 squared. So this is equal to 4.08. So the turning point TP occurs at the x value is minus 0.833 and the y value is 4.08. So let's go ahead with all of this information and sketch the curve. So the points that we had were 0 to for the y-intercept, then for the x-intercept it was 1 over 3 and 0, and also minus 2 and 0. And then the turning point is minus 0.833 and 4.08. So this is our graph. Let's go ahead and plot the points. So we have the point 0, 2. So this is 0, 0 on the x-axis, and then 2 on the y-axis. Then we have the point 1 over 3, 0. So 1 over 3 is somewhere 0.33, which is less than 1. So 0.33 is somewhere here, and 0. So this is about 0.30. And then the other x-intercept is minus 20. Minus 20 is here. And then the turning point is minus 0.833, which is somewhere here, and then 4.0. So 4.08 is a little bit above 4.0. So let's assume that it is here. So this is less than 1. Minus 0.833 is less than 1. So this point is less than 1 and it's a little bit greater than 4.0. So at the end of the day, our graph is going to look like this. This is how our graph is looking like. And this is the graph of y is equal to, into bracket 1 minus 3x times into another bracket x plus 2. Then the second part of the question is we should find the area of the finite region bounded by the curve y and the x-axis. The curve and the x-axis is talking about the area of the region in this space. So this is the area that we are supposed to find. And we know that area A is equal to integral of the lower limit to the upper limit. So the lower limit is minus 2 in this case. And then the upper limit is 1 over 3. So 1 over 3. Then the function on top, and the function on top is the curve y. And the function beneath is the x-axis. The x-axis is the same as the line y equals 0. So it's going to be integral of the function on top, and then we got that as 2 minus 5x minus 3x squared. Then minus the function beneath. So let me put all of this in big brackets. The function beneath is this line, which is the x-axis. And the x-axis is the line y equals 0. So minus 0 dx. So a is equal to integral of minus 2 to 1 over 3. Then 2 minus 5x minus 3x squared dx. So let's go ahead and do the integral. So a is equal to, if you integrate 2, you will get 2x. And if you integrate minus 5x, you get minus 5 over 2x squared. And if you integrate minus 3x squared, it becomes minus 3 over 3x exponent 3. And this is evaluated at minus 2 to 1 over 3. So a is equal to, this 3 and this 3 can cancel out. 2x then minus 5 over 2x squared, then minus x exponent 3. All of that evaluated at minus 2 to 1 over 3. So we'll go ahead and substitute the limit. So the area is equal to the upper limit minus the lower limit, which is 2 times 1 over 3 minus 5 over 2 times 1 over 3 squared minus s cubed, which is 1 over 3 cubed, then minus into bracket 2 times minus 2 minus 5 over 2 minus 2 squared minus 2 exponent 3. So the area A is equal to 2 times 1 over 3 is 2 over 3. Then 1 over 3 squared is 1 over 9 times minus 5 over 2 becomes minus 5 over 18. Then minus 1 over 3 cubed is equals to 1 over 27. And bracket close, minus 2 times minus 2 is minus 4. Then minus 2 squared is 4 times 5 over 2 becomes times minus 5 over 2 becomes minus 10. Then minus 2 exponent 3 is minus 8. So minus 1 times minus 8 becomes plus 8. So area is equal to 2 over 3 minus 5 over 18 minus 1 over 27 and minus into bracket minus 4 minus 15 plus 8. So we can find the LCM in this case, which is 54. 54 divided by 3 is 54 divided by 3 is 18. 18 times 2 is 36. Then minus 54 divided by 18 is 3. 3 times 5 is 15. 54 divided by 27 is 2. 2 times minus 1 is minus 2. Then minus. So all of this minus into brackets. I'm sorry, here was 10. There's a mistake here. This is 10. So minus 4 minus 10 is minus 14 plus 8 is left minus 6. So 36 minus 15 minus 2 equals 19 over 54, then plus 6. 54 times 6 is 324 plus 19 is 343. So this is area equals, and area is equal to, so A is equal to 343 divided by 54. So the area is equal to 6.35 square units. The area is centimeter squared of a pool of water under a leaking pipe is increasing at the rate of into bracket 4 plus 2t centimeter squared per second, where t is in seconds. Given that A is equal to 0 when t is equal to 0, find A in terms of t, and then B, the time t when A is equal to 12 centimeters squared. So the leaking rate is given us. So the leaking rate is the same as dA dt, and that is equal to 4 plus 2t. So if we multiply both sides by dt, and then all of this side too by dt, this dt and this dt will cancel. So dA is equal to into bracket 4 plus 2t dt. So we can integrate both sides of the equation, so that if you integrate the A is equal to A, and A is equal to integral of 4 plus 2t dt. So A is equal to If you integrate 4, you get 4t. Then plus, if you integrate 2t, you will get t squared. And because this is an indifferent integral, we need to add c, the constant of integration. But the question also says that when a is equal to 0, t is equal to 0. So let's put that boundary condition inside. So a equals 0 and c equals 0. So 0 is equal to 4 times 0 plus 0 squared plus c. This implies that c is equal to 0, and therefore the area is equal to 4t plus t squared. And then the b part is the time t when a is equal to 12 centimeters. So what we need to do is to replace this a by 12. So a is equal to 4t plus t squared. So a is equal to 12. This implies that 12 is equal to 4t plus t squared. So let's bring 12 to the side of the equation. So t squared plus 4t minus 12 is equal to 0. So we need to look for two numbers that when you multiply, you get minus 12. And when you add, you get positive 4. Those numbers are positive 6 and minus 2. So this becomes t squared minus 2t plus 6t minus 12 is equal to 0. So we can factorize t out in this term. So we are left with t minus 2. And then in this term, we can factorize plus 6 out. Allow with t minus 2 equals 0. So in one bracket, we have t plus 6. And in another bracket, we have t minus 2 equals 0. So t is equal to minus 6, or t is equal to 2. However, since the time cannot be negative, it implies that t can never be 6. And therefore, the time taken is t equals 2 seconds. The equation of a curve at point xy is 2x minus 3. If the minimum value on the curve is 3, find the equation of the curve. The velocity of a particle is given by v equals 3t squared plus 2t. Find the distance traveled in a fourth second. So velocity v is equal to 3t squared plus 2t. So v is also the same as dx dt, and that is equal to 3t squared plus 2t. However, the question says that the velocity traveled in the fourth second. So it means that the fourth second is the period between the third second and then the fourth second itself. And therefore, the lower limit is 4 and the upper limit, the lower limit is 3 and the upper limit is 4. So the integral of x is equal to integral from 3 to 4 of 3t squared plus 2t dt. So let's go ahead and do the integral. So x is equal to, if you integrate 3t squared, it becomes 3 over 3 t exponent 3. And if you integrate 2t, it becomes plus 2 over 2 t exponent 2. All of this evaluated at 3 to 4. So this 3 and 3 can cancel. 2 and 2 can also cancel. So x is equal to t cubed plus t squared evaluated at 3 and 4. So let's go ahead and then insert the limit. So this becomes 4 exponent 3 plus 4 exponent 2 minus into bracket 3 exponent 3 plus 3 exponent 2. So x equals 4 exponent 3 is 64. Then 4 exponent 2 is 16. And minus 3 exponent 3 is 27. Plus 3 exponent 2, which is 9. So this is equal to 64 plus 16 is 80. Then minus 27 plus 9 is 36. So 80 minus 36 is equal to, calculate the area of the finite region bounded by the curve y equals x squared minus 3 and the line y equals 1. So the curve is y equals x squared minus 3. And then the other line is y equals 1. So let's find the x-intercept by equating this to 0. So x squared minus 3 is equal to 0. So x is equal to 3. X squared is equal to 3. And if you take square root of both sides, you find out that x is equal to plus or minus square root of 3. So it means that the x-intercepts are square root minus root 3 and 0, and also root 3 and 0. Then let's equate these two lines to find the point of intersection, which is x squared minus 3 equals the second one, which is 1. So x squared is equal to 1 plus 3. So x squared is equal to 4. And if you take the square root of each side, we find out that x is equal to plus or minus 2. It means that these 2 points means that the curve and the line intersect at the points for which x is equal to minus 2 and also x equals 2. So let's go ahead and then sketch this graph. We know that the graph of y equals x squared, it looks like this. It is a parabola that is open up, and therefore the graph of y equals x squared minus 3 is a parabola that is open up, which has been shifted down by negative 3 units. So we need to shift this graph here. So let's sketch the graph. Let's assume this is our graph. And then we know that the intercepts are minus root 3. And then we also have root 3. So one of the points are minus root 3 and the second one is root 3. So since it is open up, we also said that the y-intercept is minus 3. So let's assume this is minus 3. So the graph is going to look like this. This is how the graph is going to look like. So that here is 0, this is 1, and then this is 2, minus 1, minus 2. And then here is 1, 2, and then 3. This is y. So the question says that we should find the area bounded by the curve and then the line y equals 1. So this is 1. So y equals 1 is this straight line, which is parallel to the x-axis. So the line I just draw is y equals 1. So the area we are looking for is the area of the region between this space. Now let's calculate the area itself. So A is equal to integral of the points of intersection between the curve and the line was minus 2 and 2. So minus 2 to 2 of the function on the top. And the function on the top is 1 minus the function beneath. And the function beneath is x squared minus 3 dx. So A is equal to integral of minus 2 to 2 of 1 minus 1 times x squared is minus x. Minus 1 times minus 3 is plus 3 dx. So a is equal to integral of minus 2 to 2 of 4 minus x squared dx. So let's go ahead and do the integral. A is equal to, if you integrate 4, you get 4x. And if you integrate minus x squared, is equal to minus 1 over 3 x exponent 3. And this is evaluated at minus 2 and 2. We got a as a equals into bracket 4x minus 1 over 3 x exponent 3, evaluated at minus 2 and 2. So let's go ahead and substitute the limit. So it becomes 4 times 2 minus 1 over 3 times 2 exponent 3, then minus into bracket 4 times minus 2, then minus 1 over 3 times minus 2 exponent 3. So a is equal to 4 times 2 is 8. Then 2 exponent 3 is 8 times minus 1 over 3 becomes minus 8 over 3. Then minus 4 times minus 2 is minus 8. Then minus 1 over 3 times minus 2 exponent 3 becomes plus 8 over 3. So in removing the bracket, area equals 8 plus minus 1 times minus 8 equals plus 8. Then minus 8 over 3. Then minus 1 times 8 over 3 becomes minus 8 over 3. So a is equal to 16 minus 16 over 3. And this is equal to 3 times 16. And this is equal to 32 over 3. And that finally is equal to 10.67 squared units.